Here is my solution for the fifth problem in the assignment 1 listing. So here I start off by listing all the givens. So we have that mass of the block, or mass of the bullet rather, is 0.02 kilograms when we convert it. The initial velocity of the bullet is 400 meters per second. The mass of the block itself is 2 kilos. The coefficient of kinetic friction is 0.2. And we also need to know that what the distance is that the block traveled. So it's also being carried by the bullet. So here I drew a little simple diagram of what happens before and after the bullet was embedded into the block, and a free body diagram of the block. So we can see that there are four forces acting on the block. There's the normal force, the gravitational force, the kinetic friction force specifically, and the force of the bullet. So I also set a coordinate system which says that positive y is going up and positive x is going to the right. So this is going to help us solve. So over here we know that the kinetic friction force, which I labeled FFK, equals to the coefficient of kinetic friction multiplied by the normal force. So in order to find what the normal force is, because it's not given to us, we can do the sum of all forces in the y direction. So we can see that the normal force is equal to the force of gravity, which is mass times gravity. So once we simplify and add everything together, we see that the normal force is equal to 19.62 newtons. Plugging that back in, and we can solve for FFK, which is 3.924 newtons. So now that we know all of these forces, we can use the work kinetic energy theorem. So by using EK equals W, we can expand everything in order to find what all of this means. So we can say that this force equals to FFK itself. So after simplifying a little bit, we can see that the velocity of the block is 1.9809 to the root of the distance that it traveled. So this doesn't tell us much, but we can use it in the momentum equation to solve for D. So over here we can use this because the bullet embedded itself into the block. And we can see that the initial momentum is equal to the final momentum. So that equals to m1v1 plus m2v2 equals to m1 plus m2 multiplied by the velocity of the block. So we know that m2v2, which is the initial velocity of the block, is 0 since it was resting. So we can just cross that out and say it equals to 0. And that greatly simplifies our formula. And after subbing in what VBL equals to over here, down here, we can see and simplify that D equals to around 4 meters. If we round to the nearest whole number, it equals to 4 meters. So we know that the distance the block moved after it was shot is around 4 meters. And that is the solution to the fifth problem.